Hello Internet, welcome to part 11 of MERN full stack tutorial series. In last video, we implemented resolver for add book copy functionality. We also implemented functionality of user commenting and rating a book. And while inserting the next current review, we also implemented calculating the average rating. Checked out a new branch for video 11, so let's resume coding. Let us implement the functionality to borrow a book. So for that, on user type def, let's define another mutation. We'll call it borrow a book. It will have input of type borrow book input not nullable, and the return value is updated user. Similarly, we will have a resolver for returning a book. Here the input will be of type return book input. Same thing, we will have user returned. Now let's define what is this borrow book input type. Input borrow book input. It needs two. First, owner ID. It is the user who owns the book, and the book ID, which book is going to be borrowed. Next, we need to define return book input. In fact, the return book input also need to be of same type. Input let's save it, then we will start resolving for these two mutations. In the user resolver file, let's go to the mutation ends here, so let's create one more resolver. Let's start with borrow a book. Let's write this boilerplate for now. Async try catch and also we will not need parent, we would need input from arguments. From context, let's extract user collection and me. So we would need the same boilerplate for return a book. So let's just copy this, and instead of borrow book, let's do return a book. So here also we first need to check user logged in session is valid. Otherwise, throw new error login to borrow a book. So from user input, what are the things we are going to extract or deconstruct? Constant so we would need owner ID and book ID. So let's take one of the objects. user objects and see what operations need to happen. So this is one of the users. We have this books owned. Now, if this is the user who is going to lend the book, this available needs to be marked as false. If someone else borrows this book, then this copy needs to be marked as false. It is not available for borrowing. So that is one part. The second part is the user or the member who is going to rent needs to get another uh, array with an object of book borrowed. We need to have a book borrowed with an array populated where we will have the book ID and the owner ID from who we have borrowed the book. So we need to have two operations, two user types modified in both borrow a book and rent a book. They are sort of opposite actions. So let's first do the update for owner object. Here await user collection dot find one and update. So first is the filter. The filter is ID is equal to this owner ID, and we need to pass in the second filter. Again, if you see here on the user object, we are passing the user ID and the books owned. We need to pass in the which book which we need to update this flag for. So for that we need, because this is a nested object, we need to give books owned dot book ID. This books owned dot book ID is equal to this book ID, the input what is passed. Here the second object is set operation. What we need to set? We need to set this books owned and this current index of the array. That is what this dollar sign is for. Books owned dollar available is equal to false, and let's set new is equal to true flag. So again, this operation is to update the owner's user type and update the available for that book to false. So let's call this updated owner. So if we have this updated owner, then only we need to update the borrower's object. If it is not, then we need to throw a new error. Something went wrong in borrowing book. Now if the updated owner is success, then we need to update the receiver. So for that we need same user collection dot find one and update. This is an await function. The first flag here underscore id is equal to me.id. We need to update the logged in user. Next, we need to update the books borrowed. So if I'm going to the models of this is called as books rented, we will mark it, we will update it as books borrowed, and it can't be just string anymore. This has to be book ID, which is string, and owner ID, which is also string. So we made couple of updates to uh, the models. For user model, the books borrowed is not just a string array of string, but we need to have the book ID and owner ID populated. So we need to update this books borrowed object. So here in the resolver, let's do push operation. What we are pushing into this books borrowed array. Here we are passing book ID. The book ID is this book ID what we inputted, and the owner ID is owner ID. And let's get new object. So let's call this updated user. So the updated user, if this is not successful, then again throw an error. Something went wrong, else return updated user. Now most of this code for borrow a book will be same here also in the return the book. The only thing what we need to change is we need to update the owners here as true, and we need to pop the value here in the book borrowed. So again, when we are returning a book, what we need to do is we need to set back the owner's book available flag to true, and the book borrowed, that object we need to pop. So I'm copying the code from borrow a book from here to here. The only change we need to make is here, instead of false it needs to be true. Now the operation we need to do here is this borrowed array, we need to remove that object or pop from the array. So once the owner object is updated successfully, let's do user collection, find one and update. The first is a filter underscore id is equal to me dot id. Second is the update operation. So what we are doing, we are pulling from where? We are pulling from the books borrowed. So what value we are, which object we need to pull out? So book id is equal to book id and owner id is equal to owner id. Then we will put new is equal to true flag, We'll call it updated user. The same thing if it is something went wrong and we need to return the updated user if everything is fine. So let's save all the pages, all the files. We made a change to the model and we updated the user resolver and we updated the user type def. So this concludes most of the resolvers for all the mutations we have planned for this backend. The last bit in this backend is creating the resolvers for queries with nested objects and exciting feature of creating the resolvers for pagination. So once that is done, we will move on to the front end. So let's resolve the first query, book. So on the left hand side, we have this query resolver for book. It is still pointing to that mock data we started off with. So let's change it and point it to MongoDB database. So for that, we need to call it a sync function. We have ID. We also need context, uh, book collection, and we don't need to see whether the user is logged in or not. Even the guest user should be able to see a book details. Okay, so let's call it that, and book returned it should be await book collection dot find by ID, and we are passing this ID, and the book we are going to return. So let's save it. It should be a sync. Okay. Okay, so this is working fine now. Let's go to the playground, and I typed in the query resolver. So for that, I'm taking book ID, image, title, genre, rating, and description. I'm passing an existing book ID. So let's fire this query, and we are getting the data, right? So this is all good. However, if you see this query, the book type here. So we got ID, image, title, genre, we didn't get author, and we didn't get reviews. So let's see what we will get if we try to extract the author field. For that, let's go to this query and ask for author field. Author is a nested object, so we need to find, let's get all the IDs, all the information. So name and accolades. Now we are getting this error, the field is nested. So we need to resolve for this author field within the book. So let's do that now. So far we have written the resolvers for root type query and mutation. Now we need to resolve for this root query, root type of book. So below this query or anywhere within this resolver, let's type in book, and for within that book we need to resolve for author. So let's call in author, and let's look at the first argument, first positional argument uh, called parent. It is called parent query, which we have never used till now. This is the nested object. First we are resolving for book, and after that we are resolving for field within that book. So that's where we need this parent comes in to picture. So let's save this, and let's go to, let's just first see what is there in the parent object. Our parent positional argument, we need a comma here. So let's save it again. Okay, server is looking fine. We will still not get the result, but let's see the console, what we get. Okay, so here we get the parent object from the book in first positional argument. So parent is the book which we requested for. Book, the image name, title, and author ID, and all the objects which are returned here, which are part of this book parent object. So we can use this author ID to find the author, and that's what we need to return here. So what we can do is, instead we can do the in place destructuring. So instead of parent, I'm interested in this author ID, and in the second positional argument we don't need anything, and in context we need author collection. Now, and this is an async function, we have to retrieve data from database. Next, we need to return await author collection dot find by id, and the id is this author id. Okay, server is up. Let's go and fire this query. Now we get the author details, the author ID, author 2, and the accolades for that. So wherever we have this nested objects, that's where this parent, the first positional argument, uh, comes into picture. Now let's check the reviews resolver. So we resolved author, then next is reviews. So reviews is also a nested object. It has review comment and rating. Okay, we get this error because we didn't resolve for it, and reviews is a nested object. So similar to book author, so within the book we need to resolve for reviews. So reviews, here let's say what is the parent. Let's inspect that before we implement the final function. Okay, let's bring side by side. Let's fire the query again, and we got the parent object console logged. So we have this reviews. This is what we are interested in, which is an array, and this has the object with ID, user ID, comment, and rating. So the review object itself has review comment, rating, and reviewed by. So let's first resolve for review comment and rating. So review comment need to map to this comment, and rating is rating, and we need to return an array as a return object for this reviews. So first we need to deconstruct reviews from parent. So we need to map over, let's call individual item a review, and we need to return an object. This object need to have two key value pair. So first is review comment. Review comment is equal to review dot comment, and next rating is equal to review dot rating. So when we map over the reviews, we get an array of objects with key values of review comment and rating. So we can simply return this. Okay, so let's save instead of console logging. Okay, now if we fire this query, we get review comment and review in an array. This is all the reviews we had provided for this book. Now let's resolve for the last field that is reviewed by within the reviews. So reviewed by is a user type. So I'm extracting for ID, email, name and avatar. So if I run it, I'm getting an error because I'm not resolved for it. So similar to the book, here we need to resolve for reviewed by within the review. So this is another root type. So this needs to be review below the book root type. Here we need to resolve for review by. Let's check its parent. Let's console log it and let's give comma after review root query. Okay, server is up. Now let's find the query. We will still get the error. However, let's go to the VS Code. So we are getting the user ID also. So I added this user ID because we need to get the user ID to query the user type uh, based on the parent. So even though this user ID is not used for review itself, but we need it for reviewed by. So from now what we are getting is we are getting a bunch of objects where we are getting the user ID also in the parent. So we can extract, you can deconstruct it from the parent. We not using anything in arguments. Third, we need user collection in the context, and then we need to return uh, the user collection dot find by id, and the id is this user id. So here we need to use this async function, right? So because we are using async function, let's not deviate from our pattern. Let's use try catch. If it is error, then let's do throw new error of error. If this works fine, then in the try block, let's return it. Okay. Now let's go back and rerun it. Now we are getting all the results. So if we want to for a book, we are getting ID, image, and all other um, fields here, and then we are getting the nested object of author, author ID, author name, and then we are getting the nested object of review, review comment, rating, and the next level of nested object of reviewed by is a user type and their email ID, their name and avatar, and we are getting all the two level nested fields. The resolver for reviews work fine. However, there is one problem with it. It lists all the reviews in one go. Imagine a book which has hundreds or even thousands of reviews. In that case, all hundreds or thousands of reviews will be given to the front end in one go. So the front end most probably will not have a capacity to display all the reviews, and even user may not be interested in seeing all of them, even if the front end figures out a way to display all of them. So this is a wasted resource utilization. So the way to deal with is to have pagination implemented. So at each iteration or each click, we will display only a bunch of reviews. So that pagination, typically there are two ways to implement, two methods. One is called skip and limit or page based, and another one is cursor based. So we will implement both of them in our book club project. For reviews, let's start with page based pagination. So for that, in the reviews on the type def, book type def, we need to make a couple of changes. One, we need to send a parameters or arguments to the reviews object. So first is let's call it page number. It takes in an argument of type int, and next page size. It is also of type int. And then in the reviews, remember we used the reviews in the way we use the reviews as a parent argument. So let's pass in the argument also and see what we get in the arguments. So let's log arguments here, and let's save both book resolver and type def. Then let's go to the playground. Let's wait for the server to start up. Okay, so now in the reviews, let's refresh the page. On the reviews, we should get page number. Let's start with page 1, and let's say page size is 2 review comments. Just for a testing purpose, let's start by saying that we want to display first page and each page size is 2. That means in each page 2 review comments are displayed. Now there is no change in the output. However, if you go to the VS Code, in the console we get the page number and page size. So instead of returning all the review comments in one go, we can start sending the number of reviews based on this parameter. So let us extract the page number, the arguments page number and page size from the arguments. Page num and page size from arguments. And now we need to use the slice operator on the array to get the required reviews. So let's first calculate the starting index. The starting index should be the page number minus 1, because page number we are using 1 based, and into page size. So let's say if the page number is 1 and page size is 2, so that is 1 minus 1, 0 into 2 is 0, starting position. Then let's calculate end index, should be start index plus page size. So again, with that example of page number 1, page size 2, the start index is 0 and end index is 2. So we will get the review comments 0 and 1. So if you go to page number 2, that means 2 minus 1 is 1, 1 into 2 is 2, start index is 2, and end index is 4. So we will get the review comments second and third indexed. So with that in place, instead of just sending all reviews, let's send the start and end of the slice. Let's save it. Okay, server is up. Let's go here and let's ask for 5 page size, and we want page number 1. Okay, if you fire it, we get 1, 2, 3, 4, 5. Right? And then we want the second page, and we get the next review comments 1, 2, and 3 because we had 8 review comments for this book. And if we pass the third page number, we will get empty array list. So we need to stop this from happening. So on the front end, we will have next and previous buttons. So that next and previous buttons should be displayed based on the command, based on the flag or the value sent by in this object. So we need to send has next or has previous flags based on the size we requested and based on the total reviews what we have. So let's implement that now. To implement has next and has previous, we need to modify our type def a little bit. This review can't simply be an array of review. Uh, we need to also pass a couple of flags. So let's define one more type of reviews. This reviews is another root type. This review will have has next as boolean and has previous as boolean and reviews is equal to this array of review. So we need to introduce an intermediary type because we need to pass not just the array, we also need to pass this has next and has previous flags. So the way to calculate this has next and has previous is pretty straightforward based on start and end flag. So let's define const has previous. So when the previous flag should be enabled or when it should be true? It should be true when the start is greater than 0. So the array index starts with 0. So if we are on a page where the start is greater than 0, then the has previous needs to be true. Otherwise, it needs to be false. Similarly, we need to define has next. Has next will be true when end is less than all reviews dot length. If this is so, then the hash true should be true, otherwise it is false. Now instead of passing this just array, we now need to pass an object with has previous, has next, and um, this key value pair of reviews. The reviews name is this array. So to summarize, we introduced two flags, has next and has previous. This has next is based on the end slice end index. So if it is less than length of the array of reviews, then it is true. Similarly, the has previous if the start and index of the slice is greater than 0. And we introduced a new intermediary type called reviews, which has this flags defined. So let's save this changes. Let's head back to our playground. So I made this query. We have this reviews, has next, has previous. Right, so this reviews is now a type of review. So we need to have has next and has previous. And these reviews will have another reviews with the review comment we implemented earlier. So there will be one more nested query because we this is how we define the schema. So now if we fire, first thing we still get the 5, 1, 2, 3, 4, and 5. And this is the first page. So has next is true because we have 8 pages, 8 review comments, but we are requesting only 5. And the has previous is false. This is because it's the very first page. So based on this has next and has previous, the front end will calculate next and previous buttons. So we will not encounter out of array situations. So let's just test the second page with same 5 pages, and so has next is false because we exhausted all the comments. Has previous is true because we do have previous comments. So this is the page pagination implementation based on the page uh, or also skip and limit. So in this we implemented nested queries, resolvers. We used the first positional argument to the resolvers, and we talked about what is the pagination, why it is needed, and we implemented one type that is page based. In next video, we will implement the cursor based um, pagination. That's wrap for this video. See you in next.